So our objective today is to learn how to solve equations by factoring. Now the only reason why we need to factor is if we have a term that is we have an x squared term. I can solve if there's just x's in there. That's easy. We've done that a lot. Solve for x, get the answer. But this now, I've got an x squared. So if you think back to the area problems that we covered in the last chapter, the x squareds were on opposite sides of the equation, right? So when I subtracted x squared to get with the other x squared, it ended up canceling him out. In this chapter, the x squareds don't cancel out. And so your job, you still have an x squared left over. So that's why we learned how to do factoring expressions so that you can factor these equations. So, let me find. So this is lesson 6, I think it's 8. Yeah, 6-8 out of our green textbook. And I did find any, let's see. I wanted to find, I know we had some practice from the new book. In case you wanted to get some extra practice. So in the online book, we have on page 572, there's a personal math trainer. That would be helpful. There is a personal math trainer on page 573. That's just if your quadratic coefficient is equal to 1. If your quadratic coefficient is equal to anything more than 1, then you have, let's see, personal math trainer on page 580. And 581. Okay? So you can get a lot of practice online if you need it. So let's go back and let's think about what did our expressions look like when we were factoring them. Can anyone describe our expressions? Because we didn't have any equal signs, that's why I'm calling them an expression. How were they written so that we would be able to factor them? Because there were some times when they weren't written the right way and they weren't factorable that way, so we had to do some rearranging. So how did we end up rearranging to make it workable? Yeah. So all of our expressions that we factored, as all of our equations need to be for us to solve, need to be in descending degree order. Okay, so that's super important. Now, we had talked about some example, and in our notes the first time we were dealing with it, we talked about quadratic term, linear term, and the constant. But I put numbers in there, so I want to give you what the generic is, and that's the ax squared plus bx plus c, and then because it's an equation, we would say equals 0. If any of you watched the Virtual Nerd video, it talked about solving equations using the A to C method, because A is the quadratic coefficient, B is the linear coefficient, and C is the constant or the coefficient of the third term. Did anyone watch that particular video about factoring the A to C method? Okay, so it's just talking about the coefficients, where the A, B, and C, all right? So what we need to do is make sure our equation, in order to factor, is set up properly. So number one, you have it descending degree order polynomial on one side, zero, or let's say equal to 0. So that's how we want to always write in order to do our factoring, would be the expression would be that way. But now that we're getting into equations and we have an equal sign, we want the 0 to be the guy on the other side. Okay? So that's just the basic setup for this problem. All right. So let's go through some steps that we're going to follow. To solve an equation by factoring. Number one is to make sure the equation is in proper format. So we talked about that. Proper. Descending degree order on the left equals 0 on the right. That's our proper format. If it's not that, we got to get it there. If I've got things on both sides, I'm going to get everything on one side, 0 on the other. Okay, so that's super important. Next, let's do this. So proper format again, ax squared plus bx equals c. So what I want to do is carry a problem throughout our practice. You can see it helping here. So let's have 2x squared minus 11x equals negative 12. Oh, you're right, because I was used to something else. Sorry. Let's erase him. Okay. So let's look at our example. 2x squared minus 11x equals negative 12. Good to go? Oh, we're not, because it's not in the proper format. So we're going to make sure we do our math. We're going to add 12 to both sides. And now our equation is going to be 2x squared minus 11x plus 12 equals 0. Okay, now once we have that, then we're ready to carry on with the next step. Okay, so the next step is factor the polynomial. And there's all sorts of things that could happen. There might be just a GCMF. There may be it's already factored, so that'd be kind of cool. We may play the game. We may guess and check intelligently. Okay. Again, all the game does is kind of help us streamline our thinking to figure out the factors. So I'm going to go ahead and play the game. So 2 times 12 gives me a positive 24 product, and negative 11 is the sum number. So what are two factors that give me positive 24 but add to give me negative 11? Lexi? Negative 8 and negative 3. Now, because I do have a quadratic coefficient that isn't equal to 1, I've got that too, I'm going to have to do the factoring by grouping method. So that would give me 2x squared minus 8x minus 3x plus 12 equals 0. And then I continue factoring. So these two have a 2x in common, so I get 2x times the quantity x minus 4, and then I have to pull out a negative 3, and that gives me x minus 4 equals 0. So then I have x minus 4 times 2x minus 3 equals 0. And this is when we're going to have to stop and we're going to have to discuss a property, because this property is going to be what helps us solve this. Okay. So this says these two numbers, when I multiply them, I get 0. So what has to be true in order for that product to equal 0? Lexi? Something has to equal 0, right? this x minus 4 could equal 0. This 2x minus 3 could equal 0. So what we need to do is to figure out what would make him 0 and what would make him 0. And then those are going to be the answers we're looking for. So this property I'm referring to has a very common or a very obvious name. It's called the zero product property. So it's talking about getting a product of 0, okay? So a product is 0 if one or more factors equal 0. They could all be 0. Okay? One could be 0, the other could be 0. But I have to have one of my factors equal 0 in order for a product to equal 0. It's the only way to get 0 from a product. Jason?
Or to make the 4 into 0.
Okay, we're not going to go into there yet. Okay? So in other words, algebraically, if I have a product, AB, that equals 0, so if this is true, then A equals 0, and you could say and or B equals 0. Okay? So the only way to get a product that equals 0 is that one of the factors has to equal 0. Okay? So now we go back to what we need to do here, and we're going to end up going on the next screen for me. You guys can continue on. So Jason started telling, because he wanted to jump, because he's a boy, and boys like to get to, let's go, let's keep going, let's get to the bottom line. Bottom line is, I want to figure out what x would be to make a 0. So what I'm going to do, and what the next step is take each of my factors and set them equal to 0, and figure out what those x values would have to be in order to make that whole expression equal 0. So that's our third step. Let's go. So step 3 is to set each factor equal to 0 and solve. So remember we had up here x minus 4 times the quantity 2x. No, it was x plus 4, right? Was it minus 4? And x, was it minus? Oh yeah, they were both the same, weren't they? 3 equals 0. So according to this step, what we're going to do is we're going to take x minus 4, set it equal to 0, and solve. So we have a teeny little problem to solve. Showing our work, we add 4 to both sides, and we get x equals 4. And then over here, we have 2x minus 3 equals 0. And we add 3 to both sides, and we get 2x equals 3, divide by 2, and we get x equals 3/2. Now, if you think back to that drawing I had done earlier of a parabola and noticed across the x-axis in 2 locations, it makes sense that we have 2 possible values for our x. Okay? So then the last thing we do, because we have more than one possible correct answer, is you're going to write and I'm going to give you 3 words. Solutions, that's the one we're used to, so that's the answer to the problem. Roots, that's another word that they use to represent where they cross the x-axis. And then x-intercepts, because that's literally what they are. So write the solutions, roots, x-intercepts in solution set notation. Anytime I have more than one correct answer, I use this solution set notation. So for us, solution set notation is braces, not parentheses, and not brackets. And then I just list the 2 answers. The order that I list the answers is not important. I would not change my improper fraction to a mixed number or to a decimal. Okay, that can bode for more problems. And then you just need to make sure that your answers make sense. Now that more comes into play when we get into our real world problems and you're talking about the length of something and you get a positive answer and a negative answer, you can't have a negative length. So you can eliminate that as an answer choice and focus in only on the positive one. Okay? But when it's coming to solve equations, it's usually not an issue. So let's go ahead and start doing several problems. And I'm going to start off really nicely with problems that they've done some of the legwork for you. Yes?
Does it matter which order you put
Nope,
it in?
not at all. So first problem is 5x times the quantity x minus 4 equals 0. So what's interesting about this problem?
That there's no two sets of parentheses, there's only one.
Okay. That's not that interesting. It doesn't have to have two parentheses. But according to the flow of what we're supposed to be doing, what's interesting about this? Okay. What did you say, Michael? You say something?
No.
Okay. Do we have to put this in descending degree order on one side and 0 on the other, and then do we have to factor it? They already did that for us. We're launching in to set each factor equal to 0 and solve, so half the work's already done. All we do is take each of the factors, set them equal to 0, and solve. Okay, so divide by 5, I add 4, and I get x equals 0 and x equals 4. So my answer is the set that contains 0 and 4. Done. Armand.
Why wouldn't you distribute 5x to x and x minus 4?
Because then the next thing I would have to do is factor.
Oh.
Because
so it's
remember,
pretty
we
much
have to
like a
take,
shortcut.
they've already factored for us.
Oh.
So they've done step 1 and step 2. They've made sure it was set up correctly, and they factored already.
Oh.
Okay, so all I do is launch right into the set the factors equal to 0 and solve.
Okay.
Yeah, and I got another one kind of similar. 3n minus 2 times the quantity 5n plus 8. That equals 0. So again, what they've done is gotten the equation on the left, and they've factored it. How do I know? Because I see parentheses. Okay, so, and I don't see any x squareds. So I'm not going to distribute, get the equation, and then factor it again, because they've done all that work for us. So I take each of the factors, 3n minus 2, and set it equal to 0, and 5n plus 8, and set it equal to 0. So these are going to take a little bit more work because there's more math going on. So I add 2 to both sides, and I get 3n equals 2, divide by 3, and I get n equals 2/3. So yes, fractional answers are possible. Subtract 8 from both sides, and I get 5n equals negative 8, divide by 5, and I get n equals negative 8/5. So then I write them together in solution set notation, negative 8/5 and 2/3. So let's do one that makes this work really hard, or harder. 7n squared minus 3 equals 4n. Okay, is this problem set up correctly? No. So job 1 is to get the equation on one side, rewrite it in descending degree order, and have 0 on the other. So I don't have any like terms, so I get the trinomial 7n squared minus 4n minus 3 equals 0. Now I need to factor this. So I'm looking for factors of negative 21 that add to give me negative 4. And what would those be? Negative 7, positive 3. So this becomes 7n squared minus 7n plus 3n minus 3 equals 0. And then I factor by grouping. These two have a 7n in common, giving me 7n times the quantity n minus 1. These two have a positive 3 in common, giving me n minus 3 times n minus 1 equals 0. I have the common binomial of n minus 1, and the coefficients 7n plus 3 form their own binomials. Then I take each factor, set it equal to 0 because of the 0 product property, and then solve. This one I add 1 to both sides, and I get n equals 1. This one I start by subtracting 3 from both sides, and I get 7n equals negative 3, and then I divide both sides by 7. And they get n equals 3/7. So my two answers are 1 and negative 3/7. So without understanding how to factor, we have a big problem, okay? I believe on your homework, you might have some problems that involve something that looks like this. And there's two ways to go with it. What's interesting about this equation compared to the other ones, and the ones that you typically were seeing? Good?
There's only two.
Yeah, there's only two terms. Which term is missing?
The one with just an X.
The one with just an x, who's called a linear term. If you have this situation where the linear term is missing, okay, and you notice it's a binomial, and you check to see if it's a difference of squares, it is, you could factor it, the difference of squares, and solve it. Or, because the linear term is missing, you have a second way of doing this. That second way is, let's isolate the squared term. So we add 4 to both sides, divide both sides by 25, and we have x squared equals 4 over 25. Now I want to solve for x and not x squared, so what can I do to x squared to make it x? Take the square root. But here's the deal. I want to say what number that when I take its square root, I get a different number. So if you think about it, if I take the square root of 16, what answer do I get?
4.
Is 4 the only possible answer? What's the other one? 2. Negative 4. So I actually have two possible answers, a positive one and a negative one. So anytime I put a square root symbol around a variable, I have to write plus minus on the other side. So that gives me x equals plus or minus, square root of 4 is 2, square root of 25 is 5. So I can write my answer one of two ways. I can write it as positive negative 2/5, or I could split it up into the two individual answers, positive 2/5, negative 2/5. Okay? So that's for working on your homework tonight.